today we're going to review subsets of the real number system. The first subset of our real number system is called natural numbers. Natural numbers are also referred to as counting numbers. Anytime that we are counting, we start with the number 1. So if you look at our number line here, we're going to include the number 1. And as we continue to count, we include those numbers in our subset 2, 3, 4, 5, and so on. Whole numbers are counting numbers so that means that we can include 1, 2, 3, 4, 5. But the difference here is that we're also going to include 0. So on our number line, we're going to include 0. Our next subset is called integers. Integers. When looking at integers, that means that we're including the numbers that we count, so that's going to be the counting numbers. 1, 2, 3, 4, 5, and so on. We're also going to include 0, just like the whole number. And this time we're going to include all of the opposites of the natural numbers. Which means we're going to include the opposite of 1, which is negative 1, the opposite of 2, which is negative 2, and so on. Notice that so far we've only dealt with whole numbers and their opposites. In between these points, we know that we have fractions. So now we're going to turn into our next subset, which is called the rational numbers. Rational numbers will include the counting, we're going to include the 0, we're going to include the opposite, and this time we're going to include all terminating and repeating decimals. Now, what is an example of a terminating decimal? Another word for terminating means that it stops. So if we look at the fraction 3/4, we know that that is equivalent to 75 hundredths. The decimal stops in the hundredths place. That is a terminating decimal. Now what's a repeating decimal? Well, if we look at the fraction 1/3, and we write the conversion of 1/3, we're going to get a repeating decimal. 0.3333, and so on. Repeating decimals follow a pattern. So that's why they're called repeating decimals. It's a pattern that repeats. The next subset of our real number system is called irrational numbers. Irrational numbers are not going to include counting numbers, 0, their opposite, terminating, or repeating decimals. So a rational number is any number that cannot be written as a fraction with 2 integers. going to be referred to as the crazy numbers. No repeat, no pattern, and not terminating. An example of that would be the square root of 2, 5, or a number like 4.013678, and so on. Okay, next we're going to look at these subsets in a Venn diagram. Okay, so now we're looking at the Venn diagram of the real number system. We're going to start from the bottom to the top. So let's start with our crazy numbers, which remember we refer to as the irrational numbers. So that would be this subset right here. So let's go ahead and fill this in. Remember we said that irrational numbers are going to include decimals, that are not terminating or repeating. Okay, so now let's go into the other part of the Venn diagram. We're going to start on the outside in, and you remember we said that the largest subset that we have is referred to as the rational numbers. Now, there's a symbol that we use. The symbol is Q. Q is used for rational numbers. So now, since this is the largest subset, you're going to see that the largest one includes all the other subsets, okay? That means it's going to include the integers, the whole numbers, and it's also going to include the natural numbers. So the next subset is integers, and the symbol we use for integers is Z. Now, notice that integers are going to include the whole numbers and the natural numbers, but it does not include any rational numbers because rationals do not fit. The box for the rational does not fit inside the box for the integers. So that means that it's not included there. Okay? The next subset that we have is the whole numbers. Okay? Whole numbers, we're going to use very simple symbol. Guess what it is? W. So whole numbers are going to use the symbol W. Now, again, notice that the box for the rational and the box for the integer does not fit inside the box of the whole numbers. So that means that rational and integers cannot be whole numbers. But the opposite is true. Whole number fits inside the integer box, and it fits inside the rational box. So that means that a whole number can be both an integer and also a rational. The next subset that we have is going to be the natural numbers. And the symbol that we use for natural numbers is another easy one. It's going to be N. So looking at this Venn diagram again, you can see that rational numbers, the box for the rational numbers, the box for integers, and the box for whole numbers does not fit in the natural number box. So it's not going to be included in that subset. But the opposite is true. A natural number can fit in a whole number, it can fit into an integer, and it can fit into a rational number. So what we're going to have you guys do next is fill in the Venn diagram with the numbers that you guys just did on that worksheet. And we'll come back to the Venn diagram in a little bit to see if we got these correct. Listen.